Need precise control over how your FastMCP proxy manages backend sessions, rather than relying on automatic behavior. You'll see how to explicitly define session creation strategies using a client factory pattern, giving you full control over whether sessions are shared, isolated, or customized per request. This approach ensures predictable behavior in concurrent scenarios while maintaining clean separation between frontend and backend. From FastMCP Server Proxy, import FastMCPProxy, ProxyClient. Provide a client factory for explicit session control. Def create client. Return ProxyClient, backend server pi. Proxy equals FastMCPProxy. Client factory equals create client. This demonstrates the proxy pattern with explicit session management, creating a controlled gateway between clients and backend services. The pattern acts as an intermediary that forwards requests while maintaining isolation between client sessions and backend operations. What makes this distinctive is its ability to bridge transports and manage concurrent sessions without exposing backend implementation details. The approach works by delegating session creation to a factory function, ensuring each request can operate in its own isolated context. This separation of concerns allows the proxy to handle transport bridging, feature forwarding, and concurrency management while keeping the backend server agnostic of these details. The factory pattern here enables flexible session strategies, whether creating fresh sessions per request or reusing existing ones, without modifying the proxy's core behavior. This matters because it solves the problem of securely exposing backend services across different transports or protocols. You'd use this when you need to provide a unified interface to distributed services, enforce session isolation for concurrent clients, or bridge between incompatible transports like HTTP and SDDIO. The trade-off is added latency from the proxy layer, which is why it's best suited for scenarios where security and transport flexibility outweigh raw performance requirements. Let's break it down line by line. From FastMCP Server Proxy, import FastMCPProxy, ProxyClient. Imports FastMCPProxy for creating AI-callable tool proxies and ProxyClient for explicit session management. These form the foundation for controlled, reusable connections to the FastMCP backend server. Provide a client factory for explicit session control. Def create client. This defines a client factory function, implementing the factory pattern for explicit session control. It centralizes client creation, enabling consistent configuration and easier mocking and tests. FastMCP calls this factory when it needs a new connection, rather than managing sessions internally. Return ProxyClient, backend server pi. This instantiates a ProxyClient targeting the backend server. The client factory pattern ensures each proxy request gets a fresh connection, preventing state leakage between sessions. Proxy equals FastMCPProxy. Client factory equals create client. This instantiates the FastMCP proxy with explicit client control. By passing create client as a factory function, it ensures each session gets a fresh client instance while maintaining connection management outside the proxy. This pattern prevents shared state issues in concurrent operations. Explicit session control pattern. The client factory parameter in FastMCPProxy gives you surgical control over backend session lifecycle, replacing the deprecated client parameter for explicit session management. Fresh sessions per request prevent context mixing in concurrent scenarios, while shared sessions require careful synchronization. This pattern forces you to consciously choose your session strategy, rather than relying on implicit behavior.
The proxy that forgets its sessions remembers every client